Okay. Good morning, everyone.
Good morning, sir.
So, in today's lecture, we will start with the next point, and the next point is the presentation of data. So, I'll start with an example to better get understood with a lot of small concepts those are involved. So, intelligence test is conducted. Intelligence test is conducted for 80 candidates of a certain class, and the data is 112, 77.
Excuse me, sir.
Yes,
Sir, one student is you're not allowing one student in Chris Giva.
he has named himself Johnny Depp. How could I allow him? Tell me.
Okay, sorry, tell.
Yes, tell him to rename himself. 115, 91, 137. Yes, I'll change the number. That's enough. I'll make it 40, 94, and 105. Okay. So I have conducted an intelligence test for 40 candidates, and these are the marks. Okay. So this type of data, this data is just collected. I mean, there is no processing in this, nothing, and whatever I've got, I have just put that on a paper, and this is the data. Such type of data, whichever you get, always, uh, which is not processed at all or not done anything with it, such a data is called as the raw data. Okay, it is not tabulated, it's not condensed, or no properties are done, nothing is there, just the data. Such a thing is called as the raw data. So whenever we are working with the data, the first form of data that we always get is the raw data. Now what I have to do is I need to uh, present this data. So any guess, like in your 12th standard, you have done a lot of examples on statistics. Not, I mean, not a high level, but this much you may be knowing. So how can I put this in a proper format? How can I work with this data? Anyone? If I want to
Sir,
present this data, arranging them in a,
arranging them in ascending order.
okay, anything else?
Frequency distribution.
So how will we get to that frequency distribution?
Dividing it in intervals.
Dividing it into intervals, exactly. And how we will decide the intervals? Or Shri, how will we decide the intervals? Yes,
We will, according to the like how we have the raw data. So to accommodate that, we can take even distributions.
okay. Anyone else? Akanksha?
Based on
Yes, it can be taken like from 60 to 70, then 70 to 80, and whichever scores are lying in between those, we can put it in those order.
Okay. What, Manas?
yes, it's based on a convenience. So if data is too widespread, then we have to take bigger intervals rather than short ones,
Hmm.
so that it's easy to read. And here the data is close enough, so we can take intervals of 5 or 10 maximum.
Okay. So the basic idea is we look at a range. Anyone knows what is range of a data? This is something that you have seen. What do you call a range of a data?
Sir, it is highest value minus lowest value.
Exactly. So we will look at the data, uh, and I will look at the highest value in the data. So I think it is 126 here, and
137.
137. Where do I find 137? Yes, this is the 137. Okay. So this is the highest, and the lowest one is
61.
uh, 61.
Fourth row last value.
Yes, exactly. So 137 minus 61. So that will be 40 and 30 for 80, nearly 80. 80 means आप कितना? So that will be 76,
70.
right? So this is the range. Now, depending on the range, we can actually divide the data. So if the Manas said that if the data is widespread, then the intervals could be taken large. If it is small, then in that case, for 10 points are enough, right? So depending on this range, we can actually come to some conclusion. Say, look, if I take the intervals of 10 units, then maybe I'll get 8 intervals and the whole data will be condensed. So what I will do is, the smallest one is 61. So the class intervals I will define class intervals as, say, 60 to 70, 70 to 80, 80 to 90, 90 to 100, 100 to 110, 110 to 120, and 20 to 130. Okay, so deciding this is up to you. The more, as much as condense you want, you can make the intervals as 20 also. But I have took it as the intervals of length 10. Okay. Now what you have to do is, now each of this observation, look, whatever this data is, this is called as the observation. In statistics, these are observations. These are the observations that I have, and these observations I'm going to put them in this class. So I'll tally this, tally marks. So 112, so 112, so it will come into this interval. Then 77, it will come into this. Then 115, it will come in this interval. Then 91 in this interval. 137, oh sorry, 130 to 140. I forgot the 1. And then 88 in this interval. 89, same interval. 71, this interval. 100, this interval. 93, this interval. This is 64, I guess. 64, it is in this interval. 116, this interval. 95, 95. 106, 92. Look what I'm doing here. The tally marks are done in this way. So you have got 4 sticks and fifth one like this. So this counts totally as 5. Then 84, 93, it is again here. 87, 124, 84, 117, come here. 97, 80, 103, 114, 114, 83, 77, then 94, 114, 63, has to be here, 61 again here, 120, Look at this now. So there is a very important concept here over here which is coming in. So the reading is 120. Where should I put this?
120 to 130.
Why so?
Because the lower limit is included and the upper limit is
Okay.
not.
Okay, so in there are two types. Whenever we are going to do the frequency distribution, so there are two types of frequency distribution. One is inclusive method, and the other one is exclusive method. So the one which we have done here, so that is exclusive method, in which the upper limit is not included. The upper limit, this one, these upper limits are not included in the respective class. 120, 130 and 140. These are not included in the respective class. So such a distribution that I'm doing, it is the exclusive type of distribution, because the upper limit is excluded. In some of the distributions where the upper limit is included, such a distribution is called inclusive type of distribution. Very good. So 120, it will come over here. 126, again in this. 98 here. Again 98 will go. 116 will come here. 108 will come here. 94 come. Oh, sorry. 94 and 105. So what we call this is the frequency. So what is a frequency? Frequency is the number of observations those are falling into the given interval. So that will represent the frequency. In this case, this is 3, 3, 5 plus 2. This is 7, 10 and 1, 11, 5, 7, 3 and 1. So we have got a table. So total data that we had is now condensed. Just put down in a table, and now what we have got here is class interval and the frequency. So a table consisting of the class intervals and the frequency, this is called the frequency distribution table. Frequency distribution table. So very important task whenever you are doing any statistical study. Once you get the data, you should get the frequency distribution table. Once the frequency distribution table is set, then we can go for the further studies. Now, can I ask you, what is the average intelligence of these 40 students? Is the class good? Is the class good?
Yes, sir.
It seems fair.
It seems fair. Why so? Why so? What you are
It
looking
seems
at?
to be
it seems to be average, sir, because most of the population is in the range from 80 to 120.
Yes.
So I think it seems average,
Okay.
not too intelligent or not too like dumb.
Okay. So, if you see what you are looking at, so you are looking at a frequency for above a certain limit, right? So, as Aditya said, that most of the population is above 80. Okay, and in such type of cases, what we do is, I mean, this is a particular type in statistics. It is called cumulative frequency. Less than cumulative frequency, more than cumulative frequency. So what we do is, we go on adding the entries from the interval 60 to 70, and I will go up to 130 to 40 and so on. And in the other one, we start from the highest and we go on deleting it. But such type of observations we are able to do because of this tabular form. Now in this you can see that the maximum number of students, if you see, those are in the range of uh, 80 to 120. Okay, and that's why we can say that the class is moderate. Those are not too much intelligent and not too much dumb. So uh, what we have done is, we had a raw data. Using that raw data, uh, we have derived a table. A table consists of class intervals as well as the frequencies. So such a table is called the frequency distribution. Okay, so this covers all the concepts those are required for interpreting a data, right? So I hope maximum things are clear, but still there are a lot of small concepts those I still need to introduce. So I'll go one by one now. If you have any difficulty in this, you can ask, or else I'm going for a new slide. Fine. So let's cover each and every concept now, whatever we have seen. The first one, the raw data. The unprocessed data. Unprocessed data in terms of individual observation. In terms of individual observation is called the raw data. Say for an example, income of 5,000 individuals is given to you. Income of 5,000 individuals is simply given to us, and such type of data is called the. So what is frequency? After that we saw what is. So we calculated each of the observations falling into a certain interval, and then we say that this is the frequency. So the basic definition of frequency is the number of observations in a class is called frequency. Is called frequency. Then next is the frequency distribution. Note that there is one variable frequency distribution, there's two variable, and a lot of things we need to see. So right now we'll just write down the most basic definition: a table consisting of a table consisting of class intervals along frequencies, along with frequencies is called frequency distribution. So aim in this chapter is to achieve this. So we need to find the frequency distribution. Okay. So how do you achieve the frequency distribution? I'll just summarize the method. What we did: calculate range first of all. For the data, you calculate the range. Once we get the range, what we do is divide range into n parts, whatever n parts. What do we mean by n? Number of intervals required, number of intervals that you need, n parts, and take the intervals and take the intervals accordingly. Then fourth one, classify observations. Classify observations. Depending on your class intervals, now we will have to take the observations and we'll put them into the class intervals accordingly. And then we tally marks and we get the frequency distribution table. So there are two methods of classification, as I mentioned earlier. Methods of classification, methods of classification. First one, inclusive method. So what I should write in this method? In this method, observations equal to upper limit, equal to upper limit of the class are included in same class. So say for an example, I have daily sales in rupees. So I'm making a table. So I have 2000 to 2999, and this is 3000 to 3999. This is 4000 to 4999. can see there is a disjoint, and this whenever you will have an observation, if someone is having daily sales as 2,999, it will be included here itself. But like the previous example that we solved, in that case 120 when we got, we didn't include it here, but we included it here. So the classification in which the observation is included in the class, for the observations for which observations which are equal to the upper limit are included in the same class, then such a method is called the inclusive method. The second one is,
Sir, can you tell that example of what you said about 2999?
so what is happening, say I have just defined the intervals, okay, I am not talking about the observation. So if
Okay.
we have daily cells, daily cells
Cell.
of 2,999. Now the question is in which class it will be included. So it will be included in this class, right? So you are going to give the frequency 1 over here when you see the entry 2,999. Okay.
Okay.
So this observation is equal to the upper limit of the class, right? So this
Yes.
observation is included in this class interval. It is considered in this class interval. So the upper limit is included. The upper limit is
Okay.
included. That's why this type of distribution is called inclusive. Whereas if I go to the example that we solved earlier, so for this 120 entry, I said that this was included in the next class, not in this class. Okay, so this upper limit is
Yes.
not included in this class interval. So that's why this is exclusive, because upper limit is excluded. Okay, so that's why this classification is uh, exclusive classification, whereas this one that I have written here, it is inclusive. Right. So I'll write down the definition. In this method, the observations equal to the upper limit does not belong to the same class interval. So I have 2,000 to 3,000, 3,000 to 4,000, and 4,000 to 5,000 daily sales in rupees. Again, in this data, you can see that if there is a daily sale of say 3,000, it won't be included in this class, but it will be included in this class. So the upper limit is excluded from this class interval, and hence the method of classification that we are using over here, it is called the exclusive method. Fine. So these are the things that we saw in the example. Now we'll just talk about some other definitions like class limits, lower limit, upper limit, class boundaries, class mark, class width, and the last one open end class. Yes. What is class limit? You just have to, use your logic and you'll get the correct answer. It's not so difficult. So, what do we call a class limit? As the numbers, two numbers designating class interval. Designating class interval is called the class limit. And in the class limit, there is comprise of upper limit and lower limit. These are just the terms I'm telling you. These are the terms which we will be. Be quick, it is not so difficult.
The upper limit is the highest value of the class interval, and the lower limit is the lowest value.
Highest value of the class.
Absolutely.
So whatever highest possible observation you can include in the class is the upper limit. Whatever lowest possible observation that you can include is the lower limit. Okay. Then what are the class boundaries? So you have distinct class. So for class boundaries, I'll write it down. So you have 10 to 19, 20 to 29, 30 to 39. Okay. So I'll make it continuous by say 9.5 to 19.5. This will be 19.5 to 29.5. This will be 29.5 to 39.5. So what has happened here? So the what are the class boundaries is the maximum point up to which you can extend the upper limit and the lower limit. So the class boundaries are the numbers up to which the actual magnitude of the observation in the class can be extended. Okay, so whatever number I can extend up to, such a thing is called as the class boundaries. Anyone class mark? Now it is easy.
The middle value of the class.
How do you get that? Can you tell me the formula?
Add the lower and the upper limit and divide by 2.
Lower limit plus upper limit divided by 2. This is called the class mark. Then class width.
Upper limit minus lower limit.
Lower limit.
So upper limit minus lower limit. This will give you the class width. Fine. So these are small terms for doing the interpretation of the data. In the next lecture, what you'll see is the cumulative frequency curves, and also with that, we will see the graphical representations of this data.
Sir,
Yes.
Sir, can you tell me the third method to calculate frequency